Hi, this is Vita Carmona and I'm doing the tutorial video for Project 1. The subject of solar power has gained importance and relevance in the latter years as we have realized that our current methods of attaining energy are not sustainable, and so the engineering community has taken up the challenge of finding new alternatives that are clean and sustainable. Our Excel data is this database that includes countries, classes within those countries, irradiance, which is also known as the power per unit area received from the sun in the form of electromagnetic radiation, and the kilowatts per year. Notice that this column here, it doesn't consist of a digit. For example, this first one says 4.5 to 5, and that's corresponding to class 9. Or this one down here is 5 to 5.5, which corresponds to a class of 10. So we're going to fix this here in our code. For our project, we're going to calculate the energy that corresponds to each country, as well as find the minimum energy based on the classes within each country, as well as the maximum energy for each country. Here's our logarithm, and as it says here, our input is going to be that matrix with all the data. Our output is going to be the energy in region. For our assumptions, we have this constant n, which comes from these equations that we have here. It's the conversion efficiency. And we have this conversion factor of 365 days equals 1 year. Our other variables are going to be the productive land, total land, and the conversions that are going to be needed to calculate the energy. To explain our algorithm a little better, we have our household commands, our input variables, the assumption, and we're going to convert from kilowatts per year to kilowatts per day by using that conversion factor divided by 365. And we're going to calculate the total land by dividing the rate per day by the irradiance. We're going to calculate the productive land by multiplying the total land, which is the previously calculated value here, by 0.015. I can explain this a little bit better once we're in our code. And then we're going to calculate the energy of each class in each region by using this equation here, which just uses all of the previously mentioned values as the productive land and the irradiance, the value n, and 365. And then we're going to find the average energy of each country, and then we're going to find the minimum and maximum energy according to class in each country. Now moving on to our code. Here are household commands. We use the XLS read to import the data here, and we separated the data into columns. As you can see here, class 1 is going to be that second column, the rate area day is going to be that third column, and the rate year is going to be that fourth column. We really don't use this value here, as we're going to replace it, given that it's not a digit for each. It doesn't give us digits, it just gives us a range. So we're gonna replace that. But you can see here how we divided the data. Also, we converted the data from cell into matrix in order to be able to do the calculations. So we use the function cell to mat to do this change. So down here, we inputted our conversion, or our assumptions, which is the n equals 0.1 according to the equation. And we also are going to do the change from rate per year to rate per day by dividing by 365 right here. And down here is where we make that change from that third column here that we said that it's a range, it's not a number. Here's where we made that change. So we used an if statement to replace the values of column 3. We used the if statement to determine what the irradiance was based on the class. As we said here, for example, if the class is 9 then the irradiance is going to be 4.75. What we basically did is we took the value in between the two values given in this column, and then we assigned that value to the class. That is how we replaced column 3, and you can see here we just went in order. So if the class was 1, if the class 1 was equal to 0, then the value would be 0.25. If the class was 1, then the irradiance was 0.75. If the class was a value of 2, then the irradiance was 1.75, and we just took those values by taking a look at the data and seeing what values of classes were assigned to the irradiance. And then we move on to I think I did explain this, how we convert, rate per day, we got it by dividing the rate per year by 365. Okay, so the total land is needed to calculate the energy. So we did that by dividing the rate per day, by rate area day. And then the productive land we calculated by multiplying the total land by 0.015, which is 1.5%. And this was taken from these equations here. Here are the equations in the data set, the energy and the productive land equations, and that includes the 1.5% of total land available. And then we created a function to calculate the energy. Our function is called energy calc1, and it was saved under the same name and placed in the same folder of the code and the data set so that it would work. The inputs are the productive land and the rate area day and the conversion or variable n that we mentioned before, which is the constant of conversion efficiency, 10% or 0.1. And basically this just multiplies everything together for us, and it stores the value of energy under the variable name energy. So we just rename the energy name using the first 3 letters of the first country. We sent the information or the data here, and then it's going to return the value of Afghanistan, for example, here, and store it under this variable name here. And then for the energy maximum, we just took we used the maximum function and sent in the energy of Afghanistan for it to calculate the maximum. And then for the minimum, we just used the minimum function. And for the average energy, we summed the data and then divided by 5, which is the number of inputs for that country that there were. We did that for many of the countries. This is the same thing I just explained, but for different countries. And down here, this is how we decided that we wanted to take the user input in the form of a menu. So here is where we created our menu. So the input would be out, because when you use a menu, here is a menu. This Afghanistan would be a value of 1, Angola would be 2, Algeria 3, and so on. So depending on which one the user would click, then that value would be stored under the variable name out. So depending on which one the user inputs or clicks, then we're going to display or fprintf the information for that country. So for example, if I click Algeria, oh, I'm sorry, let's try again. Algeria. Okay, there it is. So the information will come out for that specific country. So we used an if statement just basically determining if the user clicks the first option or the second option, and then we just fprintf whichever country the user is interested in. This sort of code will be beneficial to somebody working in improving the solar resources by being able to compare and see who which country is being more efficient in their use of it. This would be very easy for them to compare numbers. They wouldn't have to waste time trying to determine and calculate each time. All you would have to do if an engineer was using this, all they had to do is just change the data here and just input the numbers, the raw data, and then use this code to determine what each country is providing in terms of energy, and it would be very easy for them. The limitations of this code is we didn't include all of the countries, so for each country you would have to include the section of the code again. There it is. So yeah, this is how you use our code, and this is the explanation of how it works.